Hi, my name is Andy. Today, Shuwen and we are going to introduce the S3PRL Speech Toolkit. S3PRL stands for Self-Supervised Speech Pre-training and Representation Learning. Here, we will start by giving an overview of the whole process. First, if we have some unlabeled speech data, we can do some self-supervised learning. In self-supervised learning, what we are basically doing is pre-training some neural networks. Once pre-trained, these neural networks then can generate some meaningful representations. And finally, the pre-trained neural network and representations can be used on several different downstream tasks. Here we only list a few of them. In this talk, we'll refer to the neural network as upstream and these tasks as downstream. Our toolkit mainly provides four main features. First, the upstream pre-training. Second, the upstream hub. Third, the downstream fine-tuning. And last but not least, we support the superb challenge. We will go through each feature one by one. First, we will talk about the upstream pre-training part. Currently, we support the pre-training of three different methods. First, we have the Mockingjay, which is basically the speech version of BERT. Next, we have Audio Albert, which is basically the speech version of Albert. And third, we have Terra, which is an improved version of Mockingjay. These methods are fairly similar. First, waveform is converted into spectrograms. Then, after some downsampling, the spectrograms are randomly masked. After passing through some transformer blocks, we will generate some representations. And after a linear transform, we will try to predict the mask spectrogram, and the model are learned with L1 loss. Now we are going to talk about feature 2, the upstream hub. Here we list some popular models that we currently support. In our upstream hub, we provide an all-in-one unified interface. All these methods may come from different implementations. However, with our toolkit, you can access them easily and switch between different models, or jointly use more than one at the same time. Initializing your model is as simple as the following. You basically only need 3 lines of code, and you can build a CPC model. Here we show the first method that you can use to initialize your model. We provide an alternative method too to initialize your models. Here, you can change the string to switch between different models. Plus, we provide automatic preprocessing. All the upstream models take raw waveform as input, and our toolkit will automatically apply the corresponding preprocessing on the fly during model forward. Next, I will talk about the input and output format that our upstream models adopt. The input is a list of unpadded waveforms. The list symbolizes a batch, and each waveform should be a torch float tensor. The output is a dictionary with at least 2 keys, hidden states and last hidden states. Last hidden state is a tensor in the shape of batch size, extracted sequence length, and feature dimension. And hidden states is a list of tensors all in the same shape, same as last hidden state. However, the hidden states contains the hidden states from all the hidden layers of the model. This covers our upstream hub. Now I would like to invite my colleague Suwen to introduce the remaining 2 features, downstream fine-tuning and the superb challenge.
Thanks, Andy. Hi everyone, I'm Sun Yang. Downstream task evaluation are essentially important for self-supervised learning, since we basically know nothing by looking at the pre-training loads. If the pre-training learning scheme is too simple, you can end up very small loads but learn nothing. So we should always evaluate representations on downstream tasks to see whether the new ideas work. Hence, we provide a wide range of downstream tasks to ease this implementation burden, let you focus on new ideas of upstream pre-training and easily evaluate with our downstream modules. Instead of providing many generic speech modules and models as already done fantastically by ESPNet and SpeechBrain, we opt to provide the module for a task called Downstream Expert, which you can just plug and play to evaluate your upstream model as soon as possible. After downloading dataset like LibriSpeech, you can change the dataset path in the YAML file, which configures the downstream expert. Then, the expert will initialize the dataset and provide the suitable downstream model accordingly. After initialization, you can get the data loader from the downstream expert, which you iterate for new batches. By feeding new batches into the forward function, you get the loads and train the expert. Finally, the expert also defines how to calculate task-specific metrics and logging. Here is a very simple conceptual pseudocode on how things work. First, you import an ASR module from S3PRL downstream. Then, initialize it with the YAML config containing your LibriSpeech path and get an expert. Iterate over the data loader given by the expert and forward the batches into the expert. Finally, log the results during the model forward also by the expert. You can either use the downstream expert with your own training evaluation loop and optimizers, or you can also drive the downstream expert with well-written trainer classes provided in other toolkits like PyTorch Lightning, Hugging Face, ESPNet, and SpeechBrain. We also provide a simple fine-tuning script to serve this purpose, where you specify on the command line about which upstream model you want to evaluate and which downstream task you are interested, and then the script will do the fine-tuning. You can also specify many training hypers through command line, like learning rate optimizers or the training steps. The final feature is that we include all the tasks defined in Superb benchmark in S3PRL. So by the fine-tuning script I just mentioned, you can conduct experiments for all pairs of upstream and downstream. To benchmark a new upstream model, you can upload your model definition along with pre-trained weights to either Torch Hub or Hugging Face Hub. The fine-tuning script will then download the upstream from the internet and do the fine-tuning as before. And after the fine-tuning, the script will also generate the prediction files for each task for you to submit to our online leaderboard. Here is a brief navigation through our leaderboard website, the landing page, and some useful links, the task definition, and the rules for the submissions. And here is a leaderboard containing all the results, and you can toggle a task to choose which task you want to show on the leaderboard, or you can also rank the task importance. And before you submit, you need to first log in, like this. After logging, you can see all your previous submissions in your profile page, and you can choose one submission to show on the leaderboard. To submit new results, first you need to fill your model information like this, and then you select the prediction zip file here containing all the prediction files for each task whose format is described in the S3PRL repository. Okay, and after you upload the zip file, this will take a while. Oh, sorry. After you upload, the backend server will calculate the metrics and show the results on your profile page. And this one is our latest submission, and you can show it on the leaderboard. Okay. The end, and thanks for listening.